Hey folks, it's Mr. Defy once again. Welcome back. I'm here to continue with the previous video. This is part 2. Part 1 had to do with graphing a system of linear equations. And you can see here, this is the first video. The second video will be very similar to the first, but there is a difference, as I said at the end of that first video, and that is that these two equations are not in slope-intercept form. So therefore, I need to begin by transforming each one into slope-intercept form. So let's go ahead and get right into that right now. So starting with the 2x minus 3y equals 12. And let's go ahead and put the other one right next to that. So that would be 2x minus 3y is equal to 3. Now, to make it into slope-intercept form, which is this blue equation that you see right there, so to make it into that, what I have to do is realize that the y has to end up dominating the left side. And that means that everything else must go to the opposite side of the equal sign. And we start with the x term. So in the case of the one on the left, what I get is, if I have 2x as a term, I do the inverse, and that would be minus 2x. I transfer that over here. And these two eliminate each other, leaving only the negative 3y. On the right side, this negative 2x comes down, followed by the 12, which is positive, so I put plus 12. Then I take the negative 3 and I divide that here, here, and here. Now what that does is it leaves me with my final form, which is y is equal to. These two double negatives, when you divide, will make a positive, so this is now 2 over 3x. And a positive divided by a negative makes a negative, so this is minus 4. Now that's not the answer that we walk away with. This is just a stepping stone to get our graph. Now I do the same thing with the right equation. And I start with my x term, so that's positive 2x, therefore the inverse is negative 2x. I put that over here. Like last time, these two eliminate. I get negative 3y. On the right side, I have negative 2x and a positive 3. Now, I need to get rid of this negative 3, so I will divide, just like before. And what I get is y is equal to, now again, these two negatives, when you divide, will make a positive, so it's 2/3. And this positive divided by that negative will make a minus sign, and 3 divided by 3 is 1. So just like that, I have my slope-intercept forms. So I can go ahead and graph directly from these. Now, like last time, you need to identify the point of beginning, which is, in this case, your negative 4. And then over here, your 2/3 gives you a direction in which to move, which would be up and to the right from that negative 4. For now, let's go ahead and graph that one, and then we'll do the one on the right. So starting at negative 4, I put a point, and then I go up twice and to the right 3 times from there. So it's up twice, to the right 1, 2, 3. Where I stop is where I place my point, and then I go ahead and I create my graph. So it would be this. Okay, doing the same thing, but with the other function, I get the following. So this is my beginning, which is negative 1, and this is how I move, which is 2/3. I should indicate that's the slope. So our slope is 2/3. Now, what you might have noticed by now is that the slopes are the same. Right? So for this function, I'm still going to move up twice and to the right 3 times, just like I did before. The only difference is that my y-intercept puts me somewhere else than where I was the first time. So I'm going to start at negative 1 instead of starting at negative 4. And from there, just like before, I will go up twice and to the right 3 times. 1, 2, 3. Put my point and make my line. And what you should notice is that these two lines are parallel to each other. Now, I know the graph is not entirely accurate. By good fortune, I have a solution to that. So I'm going to switch over to this screen over here. You can see from the first example from my previous video that these two lines, when they're graphed, they create, if I can get that to activate here. Nope, it's not working for some reason. Okay, let's go ahead and switch to the other. But you can see this is from our second example. So you can see that these two graphs do indeed run side by side, parallel, and they will never ever intersect each other. For this kind of setup, there is no point of intersection. Therefore, there is no common solution. And that means that although you can graph each one independently, there is no ordered pair that would ever work on both functions at the same time, just like it did for this one over here. So for this group, we saw that the two functions that we started with, which were here, created this graph, which is here, and these two graphs of lines, they intersected at a point at -3, -2, and we tested it out. We found that, oh, when I plug in -3 and -2 into each function, it ends up working out. See, I get the same value on both sides for one function and the same value on both sides for the other function. However, with this pair, it's different. Because they never intersect, there is no common solution. There is no point of intersection. And so they will never have anything in common together. And with that, we conclude our second video. I hope that it did help you. Please check out the one before this, which was based on example 1, and I also prefaced it with a few things related to systems of equations. So I hope this helped. Please stop by, leave a message, and I'll see you next time. Bye-bye.